Hey everyone, good morning, good evening to all folks out there into the AI space or robotic space, medical imaging. So this is Puneet, your host for today at this AI Data Podcast. Um, Welcome all of you. Uh, so my name is Puneet, and then just to quickly introduce myself, uh, I take care of product at Labellerr. Labellerr is helping AI teams, especially working in robotics, help label their data quicker to ensure that improve their accuracy of robotics that they're building. And today, I'm excited to have a guest with me, a very special guest, and my alumni, Keshav Bimbraw, right? And welcome, Keshav.
Good to be here.
Cool. So we will spend next 40 minutes with Keshav on knowing more about his journey, which could be, I'm sure, would be inspiration for many of the students or researchers or aspiring researchers out there, and also an opportunity for executives in different companies who would be looking to collaborate with folks like Keshav who are into robotics, medical imaging. So, if that is an area of interest to all of you, then I think you should uh, continue to listen to our conversation, right? Okay, so Keshav, uh, let's start with quick uh, Twitter pitch introduction of yourself.
All right, cool. So I'm Keshav. I'm a PhD candidate in robotics at Worcester Polytechnic Institute in Massachusetts in the US. Uh, my research focuses on uh, um, utilizing ultrasound, medical ultrasound, for controlling robotic systems overall. So one of the things that I'm very interested in, and one of the things which I'm exploring, is how we can use ultrasound data from the forearm and use it to estimate what's happening in the hand. And by what's
Okay.
happening in the hand, I mean, can we estimate different hand gestures? Can we estimate finger angles? Can we estimate forces that the hands apply onto different surfaces while manipulating different objects? And then once we get these estimations, we can use these to control different types of robotic systems. So that's essentially what I work on.
Okay, cool. And would you mind sharing a Twitter pitch in some different words that you might want to define?
Oh yeah, sure.
What's coming to your mind?
Uh, well, let's see. I guess I can give a little bit of my background as well. So I did my undergrad in
Yeah,
mechatronics engineering from Thapar University in Patiala, in Punjab, in India. Uh, and then from there, I uh, moved on to Georgia Tech for my master's. I I got a scholarship to pursue a Masters of Science in Music Technology uh,
interesting.
at Georgia Tech, and that's where I got deeper into robotics research, a little bit of ultrasound and medical imaging, uh, and essentially looking at some of the signals that our bodies produce that can be used to control robotic systems, which was very interesting to me. And then
Okay.
after graduating from Georgia Tech, I worked in industry for a year, working on audio digital signal processing. And after that, right when COVID hit, I transitioned to WPI to pursue a PhD in robotics. And uh, during my PhD, I'm currently in my fourth year, about to finish fourth year. During my PhD, I've explored a lot of machine learning, deep learning, computer vision, image processing, uh, um, in terms of the core technology, but I've also explored like applications pertaining to medical imaging, robotic control, etc.
So, what inspired your transition from mechanical engineering to robotics? If you can put more highlight on that, and then any specific experiences or projects that sparked your interest?
Yeah. So, so I I actually did my undergrad in mechatronics. So that's kind of a relatively new. That was a relatively new course when I started it in 2013. Um,
Okay, and
at Upper.
sorry, and I would interrupt probably in between, right? So, okay, so what was the decision probably to even select mechatronics, right? Because um, this is a very common question in the mind of students when they are actually going getting into undergrad, right?
Yeah.
And there is a long list. Oh, there is computer science, there is
Mhm.
electronics, communication, there is electrical, civil, mechanical, and a lot more, right?
Yeah.
And then at that time, many of the students not don't have the covered in their head that okay, what exactly they need to do.
Yep.
All they have is some excitement for a couple of technologies out there,
Hmm.
and then there is a parents decision making out there that okay, you should do this because everyone else is also taking up some stream popular at that time and for that sort of colleges. So
Correct.
what went into at your side in your journey to chose mechatronics
Yeah.
at Thapar?
Yeah. That's a good question. So, by the way, my dad, he did a degree in mechanical engineering, and he is a businessman in Punjab. Um, and so, essentially, my family wanted me to take mechanical engineering, but
Okay,
I I was a little bit rebellious, I would say, and I was like, I'm not sure if I want to take mechanical. And then the
okay,
other options were taking CS, EC, mechatronics, or electrical engineering. Um, and so mechatronics was very interesting to me when I read about mechatronics engineering. Like, what is it? Um, um, I was like, oh, so you're not just focusing on one aspect. You're focusing on all aspects of a given system, right? So you're focusing. It's kind of like you're focusing on a more of a system perspective as opposed to that okay, I'm going to hire a 3D designer, mechanical engineer to design something, and then I'm going to hire an EC person to design the electronics of it. I'm going to hire some E person to design the electrical part of it, and then I'm going to hire some computer scientists to write the code to control it. But I think giving a systems perspective where one person can understand all aspects of the system, that's what mechatronics does. And so that overall was very interesting to me. And mechatronics has a direct link to robotics. And
okay.
robotics was something which was always
Mhm.
fascinating to me. Um, so yeah, despite my parents' insistence on that, okay, you need to do mechanical engineering, I decided that I wanted to do mechatronics.
Okay, okay. Were there anyone else who influenced the decision in your family?
Yeah, there was this one relative that I had. He was like a very like let's just say very open thinker. My brother-in-law, he uh, I talked to him about it, and after like a long discussion, he was like, this could be, this is really like the future because we have these core streams, um,
Yeah.
and these core streams have been there for a while. And yes, there's some amazing things happening in these streams, but eventually there would be a need for people who can bring things together so that people are not just working in isolation. And so
Okay.
that also really influenced my
Hmm.
decision.
Okay. I mean, one very important question before we come back to the first question, right? Um, uh, so while taking this choice,
Yeah.
uh, this question comes um, because at that point in time, you really don't know what's gonna be covered exactly. So for you at that time, it was probably some mechanical engineering, some robotics, and some combination of a couple of things.
Yeah.
As from the name, you really don't know what's gonna cover, right?
Yeah.
What's gonna be covered, and the key question while choosing all of this is like, oh, will I get placed in the best company at that point in time? Is usually the way I have seen students selecting, or in general, the decision making happen, right?
Yeah.
So, did this come to your mind as part of the selection process or not, in your
No,
case?
that did not come to my mind. If that would have been the case, I would have chosen CS because like my rank was enough for me to get into CS as well. Um, But I really did not think about that, because I come from a business family, so there's my dad's business as well, so I can always take over and work there, right? um, uh, so what I wanted to do was, I wanted to do something which was interesting to me. And so that's why I say this, like, I really enjoyed my undergrad experience, um,
Cool.
in terms of the growth that happened in me. um, and it's a major, uh, and what motivated me to come to the US. Yeah.
Okay. Cool. Cool. So just a for audience, right? And for students listening to all this, right? All of the conversation. Um, so if you want to make your undergrad interesting on the academic side as well, apart from the fun that we have in the college, right? Choose a stream which really gives you a kick, which is something that you're passionate about, and then go for it, right? Instead of just seeking, just by basing that decision just based on the number of placements or the number of active offers that in the past that college has. Right, cool. So Keshav, coming back to the origin, the key question that we have, right? So you got into the mechatronics at Thapar, right? So that was a kind of setting stone for your journey towards this field, right? In terms of the robotics, right?
Mhm.
And any other things, probably some projects or what else sort of things happened across this timeline at undergrad,
Mhm.
which really pushed you in the direction of your objectives of pursuing research.
Mhm. All right. So I think every undergrad in Thapar, like the freshers, as they call it, the first year people, they have to take a mandatory physics course. And so in that course, I had a professor, Dr. Poonam Unyal, and so by the way, I grew up learning music, Indian classical music. So I was always really into acoustics, but I did not understand the physics behind it. So in that
Oh,
case, that course was the first time that I actually understood that, oh, this is the physics behind, like, acoustics and echoes. Um, um, I remember there was like this term called Sabine, which is used to measure the intensity of sound. I'm probably messing some things up here, but um, that was like
okay.
that was very
Mhm.
interesting to me, is what I'm saying. So I reached out to the professor, and I was like, "Wow, I'm very interested in the course. I really like how you teach," and um, um, and she told me that, oh, okay, like, if
Mhm.
you like how I teach and if you like this course, then you should look at my research. So it was she who kind of like planted that seed of research. And when I went to her lab, and she used to give me that, okay, we have this system and I want you to understand it, like these electronic systems for characterization of some materials, right? And so that was like a starting point of like getting into research for me, where there is a lot of uh, there's not a set path that A, B, C, D. No, you have to explore. You will fail a lot, but eventually you'll have a better understanding of the problem than when you started, right? And so that kind of a mindset, like, I would give her the credit. And then there was this other professor at Thapar, Dr. Karanjit Korchima, uh,
Okay.
and she was in computer science, actually. I think she was doing her PhD there, but she was also a lecturer there. And I went to her as well. She was very approachable, very kind, and I was like, ma'am, I want to do some research. And she suggested that, okay, how about you write a review paper, because that
Oh,
helps a lot of PhDs and a lot
and
of
this was
researchers.
and
Uh,
this was first year.
First year, yes. Uh,
Wow.
it
Okay.
was the summer, at the end of the first year. So I would say maybe around um, um, April or May.
Okay.
Uh, and um, so I wrote a review paper with her, and she helped me throughout the process. And she was like, like, I just completely admire her, because she, usually people, when they help someone with their research, they want uh, their name on the paper. But she told me that, oh, this is your work, so you do not even need to put me as an author. and so that was like really magnanimous of her to do that. And then she also helped me get some funding to actually travel to France and to present that paper. And so that really opened my eyes. And I remember when I went to France, I also stopped by Switzerland, and I went to ET at Zurich to this lab that I really liked, this robotics lab that I really liked. I talked to the professor there because I wanted an internship, even though that didn't work out. It was just good talking to these like
Right.
like higher up people. And my experience interacting with people during the conference in France was really good. And so when I came back, I was just very pumped. And I was like, you know what, this is what I want to do. Like, this is my calling. I want to do research. And then from that paper, and because of like another professor at Thapar, he recommended me to this other to this to actually the head of Department of Robotics at IIT Delhi. And so
Wow.
I then worked there for 6 months.
Okay.
And I got like two papers out of it. It was a very intense environment, but it was it was a very productive time for me. And I worked on a lot of projects, and it was again like a period of immense growth. And it was there that I actually designed this project, uh,
Okay.
um, um, because I was very inspired by this lab at Georgia Tech, which was designing robots which would play music, which is a very weird thing to do, you know. Uh, um, and so I told Dr. Saha at IIT Delhi that, okay, I'm working on these core projects, but can I work on the side projects? You have these two robots here. I want to use these two robots to play a guitar, right? And he agreed. And uh, so I made a demonstration. I actually played the Indian national anthem with those two robots, and I
Cool.
yeah, I programmed them, and I sent that mail to this guy at Georgia Tech, and he was very impressed. And so we had a conversation, and he was like, "Okay, you can come here. I'm going to give you scholarship and everything." So that's how I got to Georgia Tech. So that's how my journey went through my whole undergrad.
Oh, so you use robots to play national anthem
Yeah, on a guitar.
uh, on a guitar.
Yeah.
You should have. So, did you make a video out of it or something like
Yes.
that? I mean,
Yes.
is,
And then
is, is it is it online, right? I mean, people can go and watch it.
I,
Okay, we would definitely take that link and then put that on the YouTube
oh,
along with
yeah.
this video,
Okay.
right? Cool.
Okay.
That will be interesting because I think that's something quite inspiring and really interesting direction on how you actually uh, used your um, interest in music and robotics to
Yeah.
actually showcase your patriotism. Cool. So this is how you landed up at Georgia Tech, right?
Yeah.
And with scholarship.
Yep.
And okay, and then from for example, so these are the couple of projects, and I think you also mentioned about with Dr. Poonam, right? You kind of did research as well.
Yep.
So and then and when is this journey? I saw your I went through your this whole journey which
Mhm.
you shared on LinkedIn as well,
Mhm.
and you mentioned that you worked with interned with Nokia Bell Labs,
Mhm. Mhm.
Mitsubishi,
Mhm.
and Google Research, right? Were they after Georgia Tech and before your PhD, or like when in the timeline all this happened? If you can put light on that,
Yeah.
and how you got into these internships
Yeah. Yeah. So all of these happened during my PhD.
during your PhD.
Yeah.
Okay,
So the first thing that happened was Google had, I'm not sure if they still have this. They had this research mentorship program. It's
okay,
very selective. And so I applied to that program at the end of the first year of my PhD. Um,
okay.
uh, and um Thankfully, I got in. I was the first person from my school here at WPI to get into that program. And so I was actually mentored by one of the directors of research at Google. And so that was a very eye-opening experience to
If you
be.
can share the name, would you like to share the name or
Uh,
not?
I think, yeah, maybe. Um, I would rather not share the name
Okay,
because
that's
I
fine.
because I didn't like share this in my profile. Like I'll probably have
Okay,
to ask him
that's fine.
before.
That's
You
fine. Yeah.
yeah. So um uh, and so like that really helped me get insight into big
Okay.
tech, right? um which previously was something that I was not really looking that deeply into. And I know like there's a lot of people, especially like in the core CS world, who
Hmm.
probably know tons about that more than what I do. But that was like my insight into that whole big tech world. Um, and so at the end of the second year of my PhD, that's when I uh, applied to Nokia Bell Labs. I actually applied to Nokia Bell Labs while I was visiting India, my parents,
Okay.
and then I got an interview, and then uh, I finally accepted the offer. And it was a very good experience working at Nokia Bell Labs. This was in New Jersey, and
Okay.
um, um, and I worked with Dr. Mingdi Zheng,
Hmm.
and I essentially worked on taking signals from the body and using it to design systems that can be used to control robotic systems.
Okay.
Yeah,
In a layman, you have to understand if you can show if you can elaborate on that.
yeah, for sure. So what I worked on at Nokia was um, so the way our we control our hands is it's very interesting. It's through electrical signals. So our brain sends electrical signals which go through our muscles to finally our fingers or to our hands or to our limbs in general. And it's very interesting that when you move your hand a certain way, let's say if I'm making a fist or let's say if I'm raising a finger, there's a separate signature to each one of these electrical signals. And so that can be classified. And so we can actually classify these signals which are going through the forearm to
Okay.
estimate different gestures that the hands are doing.
Oh,
So essentially you can use a sensor like that to estimate your different hand gestures. And you can design a system that can estimate different hand gestures. And then one of the other sensors that you can use is you can use accelerometers, you can use inertial measurement unit sensors. Again, in layman's terms, there are some sensors which can give an estimation of uh, the position and orientation of an object. So
okay.
when you put these sensors on your arm,
Okay.
you can actually train models which you can then map onto a robotic arm. So the robotic arm can do exactly what your arm is doing. So if I'm moving
Oh,
my arm like this,
got
the
it.
robotic arm will also do exactly the same thing. And if I'm opening my hand, the robotic arm's gripper would do the same thing. So
Okay.
what they were interested in, what Mingdi was interested in, was um, um, working on it more from an industrial robotics viewpoint, and so that's what I've worked on there.
And I think you mentioned other one more internship. It's
Yeah,
Mitsubishi Electric Research, right?
yes.
And what
So
was that about? Was
yeah,
it also similar related to robotics?
it was yes, it was also related to robotics, but uh, so I'm actually going to be working for Mitsubishi again this summer.
Oh,
Um,
cool.
uh, so I worked with Toshi-san there, um,
Okay.
and he's an expert. He has like tons of patents and extremely good research, and they do a lot of very good signal processing research there. Like they are experts in machine learning and everything. Like when I go there, I'm actually a bit overwhelmed because of how much of an expert they are. There's like these PhDs from MIT there also working and who are brilliant, absolutely brilliant. Um, um, so what I worked on there was multimodal uh, uh, signal bodily signal analysis. And let me explain that in layman terms.
Yeah,
So
sure.
uh, usually so we have established that there are different signals that our bodies generate,
Generate.
which can be captured and which can be used to estimate what's happening in the body or what's happening in the hands, right?
Okay. Mhm.
um, like for a lot of cases you would want your hands to be free, So you would not want to wear gloves, or you would not want to restrain the movement of your hand if you want to control something, right? So what you do, you instead bring all the sensors to the arm. And so along the same line, um, at Mitsubishi, what I worked on, and the reason I'm talking about this is because we already have a paper out on this, so I can talk in depth about it. Both with Nokia and Mitsubishi, I'm only giving out information which is out in the public domain because they have
Yeah.
very strict non-disclosure agreements. Um, so at Mitsubishi, what I worked on was that when you have a bunch of sensors and they are sending data, um, um, and this data can be used to estimate different gestures. How do we make the system more robust? And by that, what I mean is like oftentimes some of the sensors stop working, or they start giving bad data. So how do we actually train our deep learning or machine learning models so that um, despite bad data, the models perform well? So that is
Okay.
something that I investigated during my internship last summer. Uh, yep.
All right. So, some question a little bit out of the context of your journey,
Yeah.
but more around like a sort of fun question, right? So, if you were to build a robot companion
Yeah.
to assist you in your daily life, what would its name be, and what task would you entrust it with?
Yeah. I think I think that's a fun question. So, in terms of the name, I'd probably choose like a Sanskrit name because um, I don't know, something like a Robo Yantra or something. Because
Okay.
I'm really into, you know,
Upayantra.
yeah, something like that. Um, and so since I know so much about robotics because I've been in the field for, I think, and I'm not exaggerating, maybe like 10 years now. So.
Mhm.
Uh, um, um, I know what is capable and I know what is just like BS because a lot of people they overstate the capabilities of robots. So if it is something which is more uh, um, like an articulated anthropomorphic, and sorry for these terms, but essentially what I mean is like with something which looks like a human, then
Yeah.
then what I would address them with is like some very basic tasks which have no contact with a human. So let's say
Okay.
um, um, ironing my clothes or something, but I will know, like I will have to lay everything down, and then the robot is going to iron it. Or
Okay.
probably like I can probably program a robot to cook something very simple for me, like maybe a paratha or something, right? It would be great if a robot can do it in a very optimized fashion, which I
Yeah.
know, which is capable with the robotic systems. Uh, and so pretty much like activities of daily living is what I would entrust robot with, which do not have any direct contact with me, because I know that robotic systems, they're not compliant enough. And by compliant I mean like they can hurt you. The
Okay.
robots can hurt you based on how you program them because they are rigid structures, and we
Okay.
do not have very advanced soft robotic structures. There's a whole field of soft robots, but we do not. That's not very advanced right now.
Okay, okay, that's interesting. So okay, that leads to another follow-up question, right? So you are saying that there is a area where you, in your understanding, the soft robotics has to come up because they are not compliant the current way of robotics, and you are saying that if I ask you, right, 10 years from now, would
Mhm.
that be possible? Or would that be possible that these robots would be able to kind of collaborate with humans? That would be safer.
Yeah.
Is it
Uh,
like that?
yeah, I think that's a very good question. And I first started to understand what that meant during this internship that I did at IIT Delhi during my undergrad, where I was designing this robot that would play guitar. We do not want the robot to press the guitar too hard, or the guitar would break, right?
Yes.
So and also, um, um, so there were two robots. One robot was pressing the notes, the other one was plucking the strings. We also don't want
Okay.
the one which was plucking the strings to pluck it too hard, or the string would break,
Yeah.
right? So that's where I tried I got an intuition of that. Okay, compliance is very important, and we need to set the amount of force that the robot is applying. So now, to answer your question, I think we are heading in a direction where uh, a lot of robotic systems are um, going towards a direction of giving some sort of a feedback to the human,
Hmm.
which can be then used to design safer systems, right?
Okay.
So and that's also something that I have personally looked into through my research as well. um, how we can get a good feedback from the robot so that they can interact with objects in a better way, and so that they can also like not hurt humans or any other objects. So that's one thing, and another thing which is potentially a lot of people are working on is using techniques like reinforcement learning, etc. That really helps you, provided you give it a lot of good demonstrations. uh, you can train a policy which can be then used to interact with humans in a better and a safer way. Incrementally, you keep on improving a model, or you keep on improving a policy. And so because of all the advancement that's happening in the deep learning, robots are becoming safer and safer day by day. So I can envision like maybe 10, 20 years in the future, we will have very safe robots.
So, in your opinion, do you think that the with let's say you mentioned about
Yeah.
learning, right?
Yeah.
Reinforcement learning with demonstrations would make robots safer. But then, in your opinion, uh, are these robotic systems really learning at the core that what is safety here, right?
Mm, yeah, and
Or not?
yeah, that's a very good question. That's a very philosophical question, actually. What is learning actually there? Like, what is actually learning? Because what you see, like a physical robot, something that you would see in a movie like iRobot or something, a robot is one thing that I've learned is like a robot is not like an intelligent being. It's a very dumb machine. You have to literally tell it everything that you need it to do, right? So keeping uh, that in mind, your robot is just as good as your model or just as good as your learned policy, right?
Okay.
So um, if your policy is improving, and there's some great research from Nvidia, from some other places that I've seen, um, that they have been able to train robotic systems to be uh, essentially better at doing tasks. So if you can do that, and if you have some, of course, like some safety controls there, then robots will become better. And by robots becoming better, I mean the models underlying them will become better.
Mm, okay.
Yeah.
Okay. So, I mean, that's interesting. I mean, the ways in which robotics can help us assist humans.
Mhm.
Uh, Been talking to a couple of folks around marine engineering side, or
Mhm.
even to some of the companies who are actually using underwater robotics to detect mammals and even and other objects or species to to plan the safety of those species
Yeah.
and their navigation, etc.,
Yeah.
including fishing and other areas. Yeah, cool.
Mhm.
So,
Yeah.
and what's your goal finally to get into any specific application areas? Is there an area where you are getting into with robotics?
Yeah. So I'm personally very interested in the health related aspect of robotics.
Okay,
Uh, like the kind of like the unit that I work in, my lab is in the medical robotics department at
okay,
WPF. And
okay.
so something along those lines. So one of the more direct directions that I uh, am pursuing and I wish to pursue in the future would be surgical robotics. So
Surgical robotics.
yeah,
Okay.
yeah.
Why particularly surgical robotics?
Essentially, humans are error prone, right? And surgery is a very precise um, um, um,
Activity, sort of
intervention or
intervention.
of the human body, right? And so I would really like to contribute to that.
So, and when you say surgical robotics, right? What all that could be? So the surgery. So basically, this you're saying that in a live surgery, these robots would assist
Mhm.
uh, the the experts, you know, the expert person doing their surgery,
Yes.
and during that particular live surgery, right? So that's what you're saying.
Yeah.
Uh, so, and what all that activities would be like could
Yeah.
be.
Yeah. So there's two things here. One is that we train models that can help during surgery. So it's not essentially like a physical robot that is helping it, but some deep learning models that we have trained, which are
Okay.
helping with different tasks like navigation or um, removing certain tissues from the body, uh,
Okay.
cutting certain portions, looking at healing, all those type of interventional things, right?
Yeah.
That's one aspect where physical robots are not involved. But then there's another aspect as well where physical robots are involved. So one big thing there, and that's something that I've looked into, is that a lot of the times uh, we do want to have a physician do a surgery remotely, right? And so robot can be very helpful there,
Okay.
right? Another use case is that humans, we physicians, they're great, they have years of experience, um,
Yes.
but they do get tired, right? And so when you're tired, like it's hard to do that. So if you're sitting somewhere and if you're just moving your fingers and you're just doing your surgery, compared to if you're standing on your operating table and then you're trying to do it, you'll get more error there compared to like if you're sitting somewhere comfortably and
Okay.
then you're doing it. So like there are robotic surgical robotic systems out there like Da Vinci system from Intuitive Surgical. Medtronic has and there's a lot of companies which have these surgical robotic systems. Especially US especially is really adopting it. uh,
Okay.
I know a lot of medical institutions nowadays, they just for the sake of it, they will just buy like a very expensive surgical robot to say that okay, we can also do robotic surgery.
No, I think that's a very nice analogy that you made to understand like why robot is actually needed for heavy precision tasks. Actually,
Yeah,
it's going to be much more valuable. Cool.
yeah.
So another question. We are all running on short of time, but then few questions left. But if you can address in short, that will also be helpful.
Okay,
So. So, what advice would you give to students considering pursuing a PhD in robotics, especially those who are transitioning from undergrad to graduate studies right now?
got it, got it. So one advice I would give them, especially let's say if you're in early years of your undergrad, definitely do some research. It it will make you a better PhD candidate. You do not have to have research papers in order to get into a program where you'll be a good fit, but it certainly helps. So that's one advice that I would give people, and also I would say like do your research. Do not just get into a PhD for the sake of it. Like from my conversation, you would have seen that like I really like or enjoy what I do, which is why I'm doing it, and so it has to be that. Otherwise, PhD is a very long journey. It's a very frustrating journey. You can be miserable and you'll be like, why did I do this? Especially in the US, a lot of PhDs just drop out. Like I think it's a very high percentage. So that's what I would say. Like do your research um, in terms of where you want to go, where you'll be a good fit, and do some actual research, which will be helpful.
Thanks, Keshav. And from the other angle as well, so there are a couple of misconceptions about robotics and AI that newcomers coming to the field have. Any one common misconception that you would like to share?
Yeah, that it's kind of like the misconception that I had about coding. So I initially used to struggle a lot with coding because I was like, oh, it's something too complicated. I cannot get it. But essentially, it's all math, and it's not like some very hardcore, calculus, uh, something which is too deeply technical. I mean, it is technical, but the mathematical principles underlying it, it's it's relatively simple.
Thanks. So, Keshav, what are your next 3 to 5 year goals? and any message for companies who might be looking to collaborate with you.
Okay. So over the next 3 to 5 years, my plan is well, first would be to graduate and then to find like a good place for me to go to. Um, um, and what that would be is like uh, somewhere where I can do some research, but I can also contribute towards like developing a product. I think I've been in academia for a while now, so I would definitely like to go somewhere where I can have more of an impact. Uh, um, Hopefully, staying in somewhat like a similar area where I've been working on, but I'm pretty open to taking up something which is relatively new where my skills can be useful.
Okay. Something around industry academia collaboration or something like that. Is that the kind of role that you are kind of envisioning?
I guess what I'm envisioning is something in industry which has more of a academic environment, and
Right.
and there's very few places which have that. Like I know Mitsubishi uh, has something similar, like Mitsubishi Electric Research Labs. There, the culture is kind of like that.
Okay, so bonus question for the audience.
Mhm.
Any recommended resources on the internet, some blogs or YouTube channels that you follow and admire, especially those who are right now going to pursue or looking to pursue their PhD into robotics side, so that they can actually spend more time on those, and then probably might that might answer their questions.
Yeah, yeah. I'm just trying to think about this because right now the resources that I look at are very different from what I used to look at when I was doing my undergrad and I was trying to transition. Like right now, I mostly look at Google Scholar and I look at research of people, and that is what gives me my direction. Um, and that's what I admire right now. But before, there's a ton of like very good YouTube channels uh, where you can pretty much learn anything. Like I do not have anything off the top of my head because I've not been very aggressive on YouTube lately.
Okay.
so um, um, so I cannot name that, but I honestly think nowadays doing a quick Google search and
Is
that 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 works for me.
that makes scholars
Mhm.
research, right?
Yeah,
There are so many research papers. Even if
correct.
I write robotics, then there's so much that will come up. How
Yeah,
to zone down into particular paper? If you can highlight some one or two pointers, that will help.
yeah. You know, in one thing that I learned during my PhD. Uh, so I'm a very hmm, I'm someone who likes to do a lot of things all the time. So which is not really which can get a little bit messy. So one thing that I learned during the course of my PhD, and this is a very cliche thing to say in the US, especially, is to have SMART goals, where I think S stands for specific, M stands for measurable, A, I do not remember the whole thing. But if there's one takeaway from that SMART thing, it's specific. That thing has
Right.
really helped me, where I'm like, okay, this is what I want to achieve. So I need to be very specific about it. And that's what would help you with your search as well.
Okay. Cool. Oh, that's wonderful, Keshav. We would, I think we can go on and on, but as it's time to kind of wrap it up, and then and that's where I mean I would love to thank you, a bottom of my heart, right? I mean to kind of share this motivational journey. There are a couple of things that particularly students have. Uh, to learn through this conversation, right? And get inspired and get motivated. And I hope that you don't mind if anyone listening to this podcast might reach out to you once they go through this, right? And yeah, so thank you, Keshav, for your time. And all right, audience. I mean, so I think you all must have enjoyed this conversation, right? We will put those links in the YouTube. So while you are watching this video, You can go through the comments and description, and we will try to summarize. And we have tried to summarize this all these points here. And yeah, thank you for this conversation and time, Keshav.
Yeah,
Uh,
yeah, for sure. And it was great talking to you.